Hi, folks. Today we'll talk about the problem with patterns. So, were you even aware that there is a problem with patterns? If not so, maybe then that's the purpose of this presentation. Okay, so, what really is a pattern? If you can see this is a visual sinusoidal pattern. This is a square wave pattern, and this is a sawtooth wave pattern, and this is just one of the many patterns that could exist. Okay, so mathematics is often called as the branch of knowledge that deals with patterns. So the interesting thing is, when I ask somebody who's not very smart, what is mathematics? More often than not, they tell me that it's whatever is in the mathematics textbooks, right? But if I ask somebody who's smart the same question, uh, the best they can tell me is that it's a study of patterns. Or, they don't tell me anything at all. All right. So, but this is what I think it is. It's a study of patterns. So let's see what really is the problem with patterns. It's about perspectives. One perspective is that of the observer, or somebody who is doing some measurement, right? That happens to be us. So let's say we have a two-dimensional grid, and we are measuring something with respect to the other. We have, let's say, time on the x-axis and any quantity, let's say q on the y-axis. All right. So let's say we keep measuring this. Remember, we are observer. We are the observer. We are doing the measurement of some phenomenon and how that phenomena changes with respect to another phenomena, which over here happens to be time. All right, so for the sake of discussion, let's say uh, this is a pattern we are observing, right? And we keep on observing this, let's say for 1 year. And let's say after the end of first year, it suddenly changes. It becomes like this. And we are just a guy who's measuring stuff, right? So all of a sudden, the pattern that we thought has a predictability to it, right? If we wanted, we could write a mathematical function to describe it. Uh, but our thoughts are all uh, raised down to zero. The pattern suddenly changes. And what it changes into, is that a pattern at all? Is this a pattern? Is it? We could try to, do some kind of a mathematical uh, magic to come up with a function that generates this uh, this pattern, basically, or even some function possibly that can accommodate it from here till this point as well. But how do we know that after the passage of some more time, this pattern, or the pattern at the moment, which, let's say, to us appears to be this thing for 1 year, and let's say this thing for next 1 month. Let's say if we think that's all there is to this quantity that is being measured, and we say in all our glory and all our mathematical prowess and all our human desire to make things predictable, we think that okay, we found it. And let's say if we write a function that describes exactly this, it will keep on predicting this phenomena till eternity, right? Now, what is the problem with this? This seems pretty good, right? The problem is that we have no insight at all into the nature of whatever it is that is changing with respect to time. And why is it that after 1 year it changes the pattern of its behavior from this pattern to something like this? And that for all that we can measure, this 1 year, 1 month, 13 months cycle continues on like this. Why is it? This needs more investigation. And that investigation inevitably is linked to the nature of whatever it is being measured and how it, more than how, why it changes with respect to time, right? Okay. So let's explore this a bit further. So let's say, I just touch it briefly. What is randomness, right? Randomness is precisely something, if this is the time axis and this is, some quantity, we say it is truly random if you cannot predict it at all. If you cannot write a mathematical function um, that can predict the pattern of whatever it is being measured, right? But this too is deceptively simple definition. And why is that so? Let me try to explain. So let's say we come up with this kind of a graph. Uh, well, this cannot go back in time. Wait. Let's say we can come up with this kind of a graph. All right. And we have measured it for, let's say, a reasonable amount of time. What that reasonable could be is 1 year, 10 years, 1 day, whatever. But it's a finite amount of time. That is important. Who is to say that this reasonable amount of time, even if it's 10 years, does not result in an element of predictability? Let's say after 10 years, if there is a random phenomenon from the point of start of measurement t0, let's say from t0 to t10 years, it is seemingly random, and it is actually random because you cannot predict whatever is going to come next. There is no pattern, none that we can find. But for the sake of discussion, let's say we find that every 10 years, this exact same thing which is unpredictable, this keeps on happening again. Let's say this entire thing, let's say, repeats every 10 years, right? In cycles of 10 years. What does this mean? Is it random anymore? I don't think so. It's not a pure random quantity now, right? So you do get a insight somewhat into the nature of the problem. And the problem is, where do you define these um, cutoffs, so to say? How long do you keep measuring till the randomness disappears, if at all? So on and so forth. So this is a problem. And before I end this, let's just quickly see something else. The only way we can be sure of something if the generator is in our control, right? If we have a generator function, which we can define mathematically, and by the way, we can also write non-deterministic generators too, which are not entirely predictable. So over here, let's say if we define a predictable generator, let's say f of x is equal to 2x squared plus 9x plus 1. So this is a quadratic equation and it has a known pattern. So this is predictable. This is the pattern actually, which is being described mathematically, right? So this is basically it. That generators and a certain class of generators is only something which we can trust with reasonable surety that it's going to result in a predictable pattern, right? Nevertheless, maths is more than anything else a study of patterns. That's what maths is. Thank you for listening and hope it was useful.